Good afternoon, and welcome to the Management Overview of Windows NT. My name is Peter Wise, and I'll be conducting today's program. I work as a software consultant for the General International area, where one of my primary responsibilities is to spread the word about new technologies digital is becoming involved in. As part of that work, I put together this two-part seminar, which I have already presented to hundreds of customers and employees throughout Asia, Australia, Canada, and South America. It has since been adopted as digital standard introductory training for Windows NT. I compiled the materials being presented today from several sources. Some come from Digital's Windows NT Program Office, some is derived from information provided by Microsoft, and much of it is based on my own research into Windows NT. My goal today is to give you an introduction to Windows NT. I intend to show how NT fits into Microsoft's larger Windows strategy, to help you understand the major components of Windows NT, and to show you what hardware, software, and services Digital is developing in support of Windows NT. Please keep in mind that the release date for both the software and hardware is still several months away, and that many of the product's details are still being defined. With that said, let's begin our first look at the exciting world of Windows NT. Today's agenda will include a look at Microsoft's Windows NT strategy. I want to show you where NT fits in with the much larger Windows strategy that Microsoft is developing. We'll then turn our attention to what Digital is doing around Windows NT in both hardware, software, and services. We'll also have some guest speakers at the end who will be able to answer questions specifically around what Digital is doing. We'll start by looking at Microsoft's Windows NT strategy. If we look at the types of users that Windows NT is going to be designed for, they fall into several categories. You have those people who are PC cultured. And by this, I mean people who currently have high-end PCs, maybe 486 systems with large drives and large memory capacities, and they're using high-end PC applications that need that disk space and memory. You have the downsizers. These are the people who have either moved from mainframes and mini computers to PC lands, or they're considering doing so, and they need more power than their current base may have. Then you have the risk taker. These are the people that want a big jump in performance, and what they're considering doing is moving from a PC and PC-type applications to Unix workstations typically built on top of RISC processors. So the high-end PC user needs a couple of things. Number one, they want increased productivity. How do you get that? Well, one thing is through greater performance, faster speed. But as important as that is the need to have applications that are easy to use and allow you to do many complex things easily. Those types of applications today are typically found in the PC environment. People want to be able to share information and resources. In the workstation world, people are used to doing peer-to-peer networking. On the PC environment, that's much more foreign and typically involves having to buy extra software to allow you to do that. And probably as important as anything is people want to protect their investment. Our corporate customers have invested thousands and thousands of dollars on PC hardware, PC software, and PC training. They don't want to have to throw this out just to get a jump in performance. So what are the alternatives for the high-end PC users? Well, there are quite a few available today. And perhaps one of the important messages that I'd like to leave this program with is that Windows NT is only one of several solutions our customers are looking at, and all of them have their good and their bad points. Certainly one solution, the most popular today, is running Windows 3.1 or Windows 3.0 on top of DOS, typically DOS 5.0. Another one is the Macintosh operating system, System 7. This has an excellent user interface. It's very easy to set up. It's got very powerful features. But for the PC user who's trying to retain their investment in hardware, software, and training, this isn't going to make it because it really involves a complete reinvestment. You have IBM's OS/2 2.0. Certainly, this is gaining a lot more popularity. However, there are still not a lot of applications available, and you have to look at how many OS2 pilot projects have actually been moved into full production. And I think you'll find that there aren't all that many. There are also a wide variety of Unixes available for PCs. And this is especially true in the last couple of months and for the last year. You have Santa Cruz operations, Open Desktop. This is probably the most mature of the Unix versions of Unix for PCs. You also have Solaris, which is created by Sun Microsystems. And you have NextStep, which is currently being ported from Next proprietary platform over to the PC. And then finally, you have the other operating systems that don't run on a PC themselves typically, but are used in a PC LAN environment. Operating systems such as NetWare by Novell, Digital's OpenVMS, OS400 running on IBM's AS400, and so on. And these other operating systems are going to continue to be used for a long, long time. But they are things which are used in that PC-based environment. Now, of course, what we're really interested in today is Windows NT. Let's start off by giving a basic definition. First of all, what does NT stand for? Well, it's new technology. And if you're coming from an IBM or a VMS environment, I think you'll see that actually some of this technology is new. Other technology you may be familiar with already. The basic purpose of Windows NT is to provide a platform for high-end computing needs. And it's also, I think one of the things that makes it unique is it's built around a graphical user interface. There are a wide variety of operating systems today which include graphical user interfaces. Certainly VMS and Unix are two examples, where you started out with a character cell-based environment and then added the GUI later on. With Windows NT, it was completely built around that graphical user interface from the very start. Another goal of Windows NT was to be able to run on multiple hardware platforms, to no longer have DOS and Windows tied to just the Intel architecture. And we'll talk in a second about what those hardware platforms are. Another goal of NT was to incorporate many features of other modern operating systems. Because this is a relatively new operating system, the Microsoft engineers were basically able to pick and choose among some of the best features of operating systems in use today. And a little later on, we'll review what some of those features are. And perhaps the most important point about Windows NT is that it is not a layered product on top of DOS, such as you have today with Windows 3.0 and 3.1. Windows NT looks just like Windows 3.1, but underneath, it's a very different operating system. If we look at this picture, we can see that there are several versions of Windows available for several different types of systems. If I were to try to define a basic strategy of Microsoft, it would be to have Windows everywhere. Everywhere from the smallest handheld computer right up to the largest servers you can find. And this picture shows that. We have Windows NT on going from large servers to what I would call workstation class systems. These might be high-end 46s with large disk drives and so forth. And you're also going to see NT on a variety of desktop systems as well, both 386 and 486. Then you have Windows, which is layered on top of DOS, as I said before, and will be able to stretch from the notebook to the pen up to the desktop. Let me just go over to the monitor for a second and show you a few other things. We'll see in a second that you also have other versions of Windows coming out. At the high end, there's going to be a product called Advanced Server for Windows NT. This was formerly called LAN Manager for Windows NT. And then down at the low end, there's another product called Modular Windows. Modular Windows is designed to run on very small systems. This would include things like handheld computers as well as perhaps television sets that might have Windows built right into it. It's going to be a very it has the Windows functionality, but some of that functionality has been removed so that it can fit into very small devices. Again, Microsoft's strategy is to have Windows everywhere. For the mainstream computing, and I think for computing for the next couple of years, you're going to continue to see some version of Windows sitting on top of some version of DOS. And to summarize some things about this environment, the DOS Windows environment is a smaller environment than Windows NT. It's a 16-bit operating system versus a 32-bit operating system, which is what Windows NT is. It's simpler. It's what I would call ROMable, in that they've been able to reduce the size of DOS and Windows to actually fit on a chip, which is perfect for things like portable computing devices. And it's been optimized for the Intel architecture. It's really not designed for other hardware platforms. If we look at Windows NT, on the other hand, it's got some different characteristics. First of all, it's a 32-bit operating system, which makes it much more powerful. It allows it to address much more memory. However, it's much larger in size, too. And I don't think you'll be seeing NT on any handheld devices in the very near future. It's also a secure operating system, in that you have to log into the system with a username and a password in order to be able to do anything. No longer will you have the situation where somebody can just walk up to your system, turn it on, and start being able to delete your files or run your applications. Windows NT is also designed to support multiprocessors. And already, Microsoft has demonstrated systems with 8 and 16 CPUs running Windows NT. It's also portable, not from the standpoint of being able to put it on a very small device and carry it under your arm, but in terms of being able to run on many different hardware platforms. And it's got a huge capacity in the size of the files that it can address, as well as the amounts of memory it can deal with. Now, what Microsoft is doing by trying to position Windows as part of Windows NT as part of the general Windows family is to build on success. Microsoft has had fantastic success with DOS and Windows, as just about everybody knows today. If we look at the desktop devices that are available, here I'm talking about Windows, not just about bitmap-based devices rather than character cell terminals, we see that about 70% of these devices are PCs. Another 10% are Macintosh, and the rest are workstations. But predominantly, it's PCs. You have about 100 million PCs out there running MS-DOS. And of those, 10 to 15% are running Windows. Windows 3.1 is selling fantastic numbers. In fact, almost 1 million copies a month. And in fact, the sales of Windows-based applications have also outstripped the sale of DOS-based applications, which means that not only are users starting to adopt Windows, but the application developers are building their applications around it as well. And as you'll see, both from a user standpoint as well as from an operating system standpoint, Windows NT is a very natural next step in the evolution from DOS and then to Windows. Windows NT is really the next logical step for the PC world, and as we'll see, it provides many modern operating system features. Now, those of you who have a great deal of experience with VMS or with Unix will recognize a lot of these features, and they may not seem very unique to you. However, to the person who's grown up using a PC, some of these features are very different and very new. The first of them is preemptive multitasking. Multitasking is the ability of a computer to basically allow multiple applications to run simultaneously, where each application is allocated a slice of time to run on the CPU. Now, Windows on top of DOS gives you a form of multitasking called cooperative multitasking, but that's really a benefit and a capability that is provided by Windows. DOS itself is a single tasking operating system. The preemptive part means that certain applications can run at a higher priority than other applications. So that, for example, you would want to have a file server application perhaps running at a higher priority than a background printing task. And a little later on, when I show you a demonstration of Windows NT, you'll be able to see that preemptive multitasking at work. Another feature of Windows NT is that it supports multi-threading. In Windows NT, when you start up an application, what's actually happening behind the scenes is that you're creating a process. A process includes at least one thread. So you can think of a thread as a unit of processing. Now, what you can do with Windows NT is you can have several units of processing running parallel. If you want to think of an example of where multi-threading might be a very powerful feature, look at a file server application. With multi-threading, you could have a separate thread responding to each user's request for a file, versus a single threading environment where you'd first have to go out and get the file for the first user, then the second user, and then the third user, and so forth. Now, multi-threading can be especially beneficial on a multi-processor system, because with Windows NT, each thread can run on a separate processor. With a single processor system, multi-threading can also provide an increase in performance. And again, when we get to the demonstration, I'll show you how that works. Windows NT also includes virtual memory. Virtual memory is the ability of the system to go out and deal with and address much more memory than is physically available on the system. So you may have a large database application that has to use 100 megabytes of memory, but you only have 32 on your system. So it can go in and swap in the pages of memory into physical memory when they're needed. Again, if you're familiar with how VMS or Unix virtual memory works, it's very similar. Another real nice feature of Windows NT is that networking is built in from the very start. In other words, you're not going to have to go in all cases and add networking as a layered product. It all depends as to what you want to do. But there is your basic networking capability built in there, which will allow you to hook up your Windows NT to existing LAN manager and TCP/IP systems. In addition, there are a lot of networking packages being developed for Windows NT. And we'll talk about some of those as we go along today. Windows NT also supports volume shadowing, which is the ability to have the data on one disk duplicated on a second disk. This can be very useful, especially for server applications, because if you have a disk go down on a server, you can put a lot of people, render a lot of workstations useless very quickly. With Windows NT and the volume shadowing feature, you can fail over to a shadow disk fairly quickly. And then finally, as I mentioned before, Windows NT has security built into it. This security means that a user has to log into the system, and that users and system managers can apply security to things like files and directories, as well as to applications and other functions on the system. Now, I said before that PC users want to gain an increase in performance. They want to gain access to those features I just listed, but they also want to retain their great investment in software, hardware, and training. And let's look at how Windows NT is assuring that those things can be done. With Windows NT, you'll continue to be able to run most DOS and 16-bit Windows applications. So if you went out and spent $300 last week on a spreadsheet application or a word processor, you're not going to have to get an NT upgrade unless you want it. You also will be able to run new Windows 32-bit applications. These are going to be the applications that take the most advantage of Windows NT and give you the greatest performance. In addition, you'll be able to run applications written for OS/2 and POSIX. Although, as we'll see in a little while, the OS/2 and POSIX support are fairly weak at this point. And finally, if you've got customers who have gone out and spent hundreds of man-years developing X-Windows-based applications, so either based on the X Windows system or DEC Windows or Motif, they'll still be able to run those on their existing VMS or Unix system and display the output on their Windows NT workstation by using an X Windows based X server. And we'll go into the product which digital will provide to allow you to do that type of thing. I had the opportunity as part of the research for this course to attend a developers conference last summer in San Francisco. This conference was put on by Microsoft, and it was designed to give people a first look at Windows NT. Now at this time, no more than a couple of hundred people had actually seen Windows NT in operation. But there was already enough awareness in the marketplace that more than 5,000 people attended this conference. And it overflowed the Moscone Convention Center in San Francisco. It was really quite a sight. More than half of the people there were application developers. And this bodes well for people who are looking for applications to run on Windows NT. There have already been several hundred applications which have been announced by Microsoft as being available either right away or very soon for the NT platform. Now, the way that conference worked was there would be speakers who would speak for about an hour, and then there'd be a question and answer session. And there were some interesting trends which I saw in the way that people asked questions. The DOS programmers and the PC users were confused by a lot of the things that we might take for granted. Concepts such as threads, virtual memory, multiprocessing, and so forth. The Unix and VMS people, on the other hand, were confused by a lot of PC terminology. For example, DLLs, or Dynamic Link Libraries. You have DDE, or Dynamic Data Exchange. A lot of PC LAN networking terminology were all confusing to the Unix and VMS people. So what I think you're seeing here is a real clash of two different cultures. You've got the DOS on the one hand, you've got the mainframe and mini-computer people on the other hand. And this represents both a challenge to digital and its customers, as well as an opportunity where digital can leverage a lot of their experiences in both of these worlds and help the transition to NT to become easier for our customers. Now let's take a look at some of the design goals of Windows NT. If I were going to name probably the chief design goal, it's to move out of the shadow of DOS. DOS, because of its history, has a lot of shortcomings. I mentioned one of them earlier, which is single tasking. We'll go into some of the others later on. Certainly one of the shortcomings of DOS was it only ran on Intel systems, 8086, 8286, 386, and 486. With Windows NT, right from the very beginning, it's going to run on 3 different hardware systems, and very soon after that, a 4th hardware architecture. And in a few slides, I'll go into what those are. Certainly another goal of Windows NT is to be scalable, to allow you to run on everything from very low-end desktop systems, or fairly low-end desktop systems, all the way up to high-end, possibly multi-processor servers. And certainly to be able to provide levels of security. Initially, it'll be able to be put into systems which will be rated at a C2 level of security, which basically means discretionary access control. And then the goal is that in a future release of Windows NT, have it move to a B level of security, which implies mandatory access control, as well as various levels of security, such as secret and top secret and up above that. Some other goals include, as I mentioned before, preemptive multitasking, multi-threading, and the support for multiprocessing. An important point here is that all of these features are built into the operating system right from the very beginning. So they're not things that you get as layered products. The next point is that Windows NT is designed to support multi-user network-based computing in the sense that it's client-server. Okay, this is an important point. Windows NT is not designed to be a multi-user system in the classic sense of VMS or Unix, where you have many people logging in from character cell terminals to one single system. Instead, it's much more designed for having servers which can serve files or applications or other resources being accessed by desktop devices running Windows, Windows NT, or perhaps even Macintosh environment. With all of that said, I'd also like to mention that there is a third-party company called Citrix, C-I-T-R-I-X, which is developing a multi-user version of Windows NT. And then the final point is that Windows NT was designed to support the international market. The chief way that they're doing this is by using a new kind of coding scheme called Unicode. And we'll be talking more about Unicode a little later on. One of the key features that Microsoft designed into the system is what I would call extensibility. Extensibility to me means that the operating system will be allowed to grow and to change and to have new features without actually having to go in and rewrite the operating system itself. Microsoft recognizes that it cannot be all things to all people. It recognizes also that there are lots of software development companies out there who want to make some money by adding value to Windows NT. So what Microsoft has done is they've concentrated on the basics of the operating system and the user interface. And they've provided literally hundreds of APIs which allow other companies to add new features. Already, as Windows NT is in beta test, customers and Microsoft themselves have recognized that there are areas where there needs to be additional support. Certainly one place is in the area of network protocols. And what Microsoft has done is they've added software hooks or APIs throughout the operating system to allow people to add new protocols. Digital, for example, is adding DECnet as another network protocol. Banyan is talking about adding Banyan-Vines protocol. Novell is adding their IPX protocol as well. Another area is 3D graphics. Right now, Windows 3.1 as well as Windows NT is a two-dimensional graphics environment. But there are certainly a lot of people out there, a lot of companies that want to move their 3D applications over to the Windows NT environment. So Silicon Graphics, for example, is moving their OpenGL 3D environment over to Windows NT. And there are already companies that are planning on creating applications using OpenGL. Windows NT already has support for 3 different file formats, which I'll be listing in a little while. There has been suggestions that additional file formats might be useful as well, perhaps one optimized for transaction processing or certain network type dealings and transactions. Those can be added, again, through APIs. And there's also the thought that there may be a need for additional APIs which Microsoft hasn't even defined yet. Good examples might be some type of a translation API which would perhaps automatically translate text from one language to another, or perhaps a speech recognition APIs. I'll let your imagination go from there and think of other APIs that programmers might see a need for in the future. Another big goal of Windows NT was that the code had to move easily between different processors, not just the operating system itself, but also applications. There's initial support in Windows NT for 3 and soon to be 4 processors. The first release of Windows NT will support the Intel architecture and will run on the 386, 486, and Pentium systems. There's also going to be support for workstations built on the MIPS 4000 chip. And finally, Digital will be providing, is working with Microsoft to make sure that the operating system runs on our Alpha AXP system. And I'll be telling you a lot more about the Alpha PC in a little while. And then the last entry is the Intergraph, a maker of high-end workstations as well as workstation software for doing things like electrical engineering and design and mapping. They have a chip architecture called the Clipper, and they're going to be porting Windows NT over to that Clipper architecture. That doesn't look like it'll be available for the first official release of Windows NT, but you can expect it sometime in 1993. Now, how did Microsoft make it so that the operating system was really quite portable between these different processors? And what are the things that these particular processors share? Well, all of the architectures which you saw listed on the previous slide incorporated what's called little endian byte ordering. Whenever anyone comes up with a new hardware architecture, they have to decide what way a byte is going to be read and how the individual bits within that byte are going to be read, either from left to right or right to left. And it just so happens that Intel, MIPS, Alpha, and Intergraph all use the same little endian architecture. There are other architectures, for example, Sun's SPARC systems, HP's RISC system, IBM's RISC system, which use high endian byte ordering. Now, the people at Microsoft say it's really not that big a task to move the operating system over to that high endian systems. What is apparently more of a problem and will require more work is transforming all of the data files which are associated with an operating system and all the applications from the little endian to the big endian. The way that they really achieved the portability of Windows NT, though, was to rewrite the operating system almost entirely in C and in C++, and to isolate as much of the operating system code that was dependent on hardware into a special area of operating system code called the hardware abstraction layer, or HAL code. So rather than having hardware dependencies spread through the operating system, it's put all in this small layer. Let me go to the board for a second and show you where the HAL layer would look within the general context of the hardware and the rest of the operating system. Okay, down here we have our hardware, the hardware. Up here we would have the operating system, and a certain section of that operating system would be the HAL layer. And all the portable parts of the operating system go through this HAL layer. It's only those parts of the operating system where you either have to have maximum performance or where you need to have hardware-specific information that it goes and it bypasses the HAL layer. Don't worry, you'll have some better diagrams of this later on in your handouts, but I just wanted to show you where HAL fits in a general sense. Another goal of Windows NT was that it be a reliable and a robust operating system. If you're going to have Windows NT being positioned as an enterprise-wide operating system and being used by mission-critical applications, you can't have it going down all the time, crashing either through poor application design or through people getting in and messing around with the operating system. So Microsoft has built in several different mechanisms to keep the system up and running all the time. One method is through adding the security which I talked about, where you have to have a username and password to get into the system, and then you can have access control lists applied not just to files and directories, but also to applications and other operating system functions. Another thing is that they've done as much work as possible to prevent a single application from crashing the whole system. And there's a couple of ways they do this. First of all, Windows NT, each application under Windows NT runs in its own private address space. There are also very few opportunities where an application can directly access the hardware. So in between your application and the hardware itself, there are a variety of protective mechanisms to prevent the system from crashing. There's another feature which is called structured exception handling, which is basically a way of recovering from serious errors such as having a disk offline or perhaps doing some illegal instructions such as dividing by 0. Not only can programmers include structured exception handling in their applications, but the operating system itself contains this exception handling code. And finally, you have the concept of individual message queues being used by every application. Previous to this, under Windows 3.1, for example, all applications used the same message queue. So if you had one application which wasn't processing the message queue correctly, you might have the whole Windows environment freeze up. And I'm sure some of you Windows users have seen what that's like. With NT, that's no longer going to be the case. Now, we've talked a lot about the expanded features and the new capabilities of NT. But again, compatibility is a very important issue. For the application programmer, this means being able to move existing Windows applications over to Windows NT as easily as possible. As programmers are finding out already, the 32-bit API, which comes with Windows NT, is very similar to the 16-bit API of Windows 3.1. And in fact, there's some excellent documentation that tells you exactly where in your application you need to make changes to get it to recompile and run under NT. From a user standpoint, the user interface of Windows NT looks exactly like Windows 3.1. Actually, there are a few changes for some new applications and some new capabilities, and I'll show you those during the demonstration as well. We said before that there's the compatibility of existing Windows 16-bit programs running. And finally, you can continue to run DOS programs, certain OS/2 programs, and POSIX applications, although all of these are character cell based only at this point. Another feature, as I said earlier, was the support for multiprocessing and scalability, so that you can run Windows NT on very small to very large systems. Let's talk about the multiprocessing. Windows NT has already been demonstrated running on an NCR 3000 system with up to 8 processors and a sequence system with up to 16 processors. By the way, these processors are Intel. In the future, I think you'll see Windows NT running conceivably on processors with on systems with hundreds of processors, although this won't be true in the first release. There will be an upward limit, and I'm not sure at this point whether that's 16 or 32. In the future, you'll see Windows NT running on laptops as well as all the way up to servers. As you know, if you follow the industry, laptops are becoming more and more powerful. And I don't think it'll be more than a year or so before Windows NT will be able to run on some of those very portable systems. Now, the way that all of this capability is supported is through the use of threads and the support of the portable characteristics of the operating system, such as the HAL layer. Another thing about Windows NT is that it was specifically designed to support distributed computing or client-server computing. Now, in order, what you're trying to achieve with client-server computing, as I'm sure a lot of you are aware, is to be able to spread the processing around the enterprise. For example, if you have a database application, you may want to do the user interface processing right on the desktop. But you may want the database management being done off on the mainframe or the mini computer. You want to be able to use systems that are sitting out there not being used today to their fullest extent. So you want to be able to use excess resources. And you want to make it easier to share data between many systems. Now, how do you do distributed computing or client-server computing? Well, you need a couple of things. You're going to need networking, and you're going to need some method of exchanging data back and forth between those systems. And as we'll see, a key component of Windows NT is the support for the remote procedure calls that allow you to do that. Let's talk about networking first. Windows NT, right from the beginning, will have support for 2 LAN manager transports, including NetBUI, or the NetBIOS Extended User Interface, which is currently used today in a lot of LAN manager and DOS environments. And there will also be support right out of the box for TCP/IP. So the people who install Windows NT on their PCs can immediately start tying into TCP/IP networks. And with the release of PathWorks, you'll also have the DECnet support added, as well as the capability of PathWorks to coexist with the NetBEUI and the TCP/IP environment. So for now, anyway, that covers the networking part of it. The other part is adding the capability of sending messages and data back and forth. And the way Windows NT is going to achieve that is by incorporating remote procedure calls. There are currently two standards for remote procedure calls, one which was defined by Sun Microsystem, the other one by the Open Software Foundation's distributed computing environment. Unfortunately for digital, which also supports the OSF-DCE, Microsoft has chosen to adopt that standard. In fact, what they did is they took the VMS implementation of DCE remote procedure calls and moved that over to Windows NT. Now, what remote procedure calls allow you to do is now to start integrating and communicating with other DCE-compliant servers and clients. What are these servers? Well, they might be systems running OpenVMS, Ultrix, some other form of Unix that supports RPC. It might be OSF1, or it might be PCs that are currently running some version of remote procedure calls. Now, for those of you who are very familiar with what DCE means and what it stands for, you may be asking about some of the other DCE type support. And Windows NT today is not fully DCE compliant. For example, it doesn't support the DCE name service. However, with the advanced server for Windows NT, which was formerly called LAN Manager for Windows NT, there is the capability of doing many things which a name service allows. For example, keeping a centralized database on a server of the names of users and their account information, the PCs and their configuration, as well as various networking configuration information. A second component missing from DCE is a time service. A time service allows you to coordinate system time among many different systems. While Windows NT does not support the DCE time service at this point, they do have a time service of their own, which they will be releasing as part of NT. And finally, a third component which is missing is Kerberos. Kerberos is a technology that was developed first with Project Athena at MIT. And Kerberos basically allows you to enforce on a network-wide basis security on applications. Under Kerberos, when a user logs into the system, they're granted certain tickets which allow them to start up certain applications. Microsoft has said that in a future release, they will add Kerberos support. But again, for the first release, it's not there. Thus, NT cannot be considered at this point to be a DCE secure environment. However, in the future, that may very well change. At this point, we have a question from Orlando. Hello?
Hello. The question was relative to support for the NFS mounting of file systems. You mentioned TCP/IP support, but a lot of customers would need the ability to NFS mount file systems.
Yes. Microsoft and Sun at Comdex demonstrated a version of PC NFS, which is a Sun Microsystems product running under Windows NT. So that will be available to users.
Okay. And another question was relative to support of DCE. Is Digital committed to support fully the entire DCE capabilities on Windows NT with our Alpha AXP systems?
The goal with Alpha AXP is to provide the same capabilities as you will see on the Intel and the MIPS platform. In other words, we don't want to start adding features to the operating system itself specifically for the Alpha platform, because the fear is that we'll fall into the kind of the Unix trap, if you will, where you have these different versions for different hardware platforms. So while some of those DCE features may be implemented as layered products, in terms of complete operating system integration, we're really going to have to work with Microsoft on that. And Microsoft said, that they'll support it as they see a need for it in the marketplace.
Well, relative to that, I've heard that the DCE support that Microsoft is putting in there is not really DCE, but is their own homegrown implementation. Will this really provide compatible DCE so people can have interoperable applications, or will we be in a situation where it's going to be a proprietary version of the DC protocols?
I think in the area of remote procedure calls, that's not going to be a problem because, again, they're working very closely with digital to make sure that it's compliant with what we're doing. In terms of some of the other features that we saw, the name service and the time service, that may in fact be a problem, and we need to follow that and see how it works out.
Thank you.
Okay, we have a call from Los Angeles. Hello?
Hello, this is Steve Utica in Los Angeles.
Hi.
I was wondering with regards to the porting a X-Windows-based application to Microsoft Windows, are there any tools or APIs to allow folks to do that, or basically do you have to rewrite that GUI interface to your application?
Basically, you have to rewrite the user interface for that application, unless you're talking about doing the remote display from a VMS or a Unix server. However, also keep in mind that there are a lot of third-party tools. For example, there's a product called XVT, which allows you to write user interfaces which can be then displayed on a variety of different environments. But that, too, would take a rewriting. So the answer is yes, you will have to rewrite the user interface code.
And that's typically a fairly major effort then, eh?
Yes.
Thanks very much.
You're welcome. Okay, hello, Montreal.
Yes, hi. You spoke about design goals for NT, and one of the things that really surprises me is that there seems to be a lack of multi-user support as we in the Unix or VMS world define it. What is the reason for that? I know it's not part of your presentation, the technical side, I understand, but what is the reason in terms of marketing that they don't have multi-user support as VMS would have?
Well, I think the main reason goes back to what I said before about Microsoft's strategy being to have a PC on everybody's desktop, a PC running some version of Windows. If they're not out there to boost the number of VT320s that people are using. So in a way, supporting the client-server environment instead of the classic multi-user is a way of getting more people to, I think, move into that Windows-centric world that Microsoft would like to see people at.
Seems like they're overlooking a lot of the heritage systems out there.
Well, yes and no. That's certainly true in some respects. You will have the ability from, using something like an NT terminal emulator to tap into those VMS and Unix systems using, a character cell-based terminal emulator. In addition, you may see people writing more client-server-based applications which allow you to run things on the VMS or Unix system and to generate a user interface on the PC and do things that way. But of course, that will take some rewriting of applications for the most part. Does that answer your question? Okay, we have a call from New York City.
Yes.
Hello.
Peter Ellis here, Sales Support, New York Financial Group. Understanding that NT in its first implementation will include quite a few of the capabilities of VMS, such as volume shadowing, and I understand that ultimately it will include clustering capabilities as well. How are we going to be able to differentiate in the sales cycle between the NT opportunities and the VMS opportunities? Also bearing in mind that desktops are proliferating. They're all over the place. A sales rep has to make a decision, or may have to help the customer make a decision as to which platform would be most appropriate. I've got a VMS server environment which has the clustering capabilities, now supports OpenVMS through Alpha XP. I also got the capability of doing that with NT. What is Digital's posture in helping to differentiate VMS, or is VMS, do you see VMS being phased out? Do you see NT systems occurred in there's an incursion into VMS sales here?
Okay, I think that in the future you will possibly see NT sales moving into some of the VMS space, but I think for at least for the near future, there's not going to be that much of an overlapping, if for no other reason than Windows NT right now is a very immature operating system. It's only in beta test right now. It won't be fully released until May. And in talking with a lot of customers over the last few months, the ones that have the truly mission-critical applications are very hesitant at this point about moving to an operating system which has not really been fully tested in that type of a mission-critical environment.
Right, but Peter, you and I both know the marketing cloud of Microsoft, and their goal definitely is to reverse that trend. Furthermore, one of the points that you made was that NT will in fact be running on multi-processor systems, parallel processing systems. So clearly the die is cast, and NT will become an industrial strength operating system in a very short order.
Okay. What we're going to have to do, I think, is to wait and see what the Windows NT marketing people do in terms of helping us position NT against VMS. One of our guest speakers later on today will be Bill Story from the Windows NT program office, and perhaps we can defer that question to him and see if he can help us out with that.
Okay. Well said. Thank you.
Welcome back. Prior to the break, we looked at an overview of Windows NT and its basic characteristics. What we're going to do next is we're going to look at the full family of Windows operating system versions. But before we do that, let's just take a little step back in time and look at the evolution of the Windows products, which has finally resulted in NT. We start out with the DOS operating system, which was developed by Microsoft approximately 10 years ago. It was originally designed around the 8086 and 8088 processors from Intel. Though the earliest operating system, the earliest DOS operating system, had some fairly limited capabilities, especially when you compare them with operating systems today. For example, it could only really address a megabyte of memory. So DOS had to work within this 1 megabyte restriction. Now, with that, you had about a third of the operating system being taken up just by system startup and loading some various hardware device drivers. So that left DOS with only 640K of available memory to work with. And not just DOS, but all of the applications that you're running as well. So even up to today, people still talk about the 640K barrier that DOS comes with. And I'm sure that if you've used PCs for any amount of time, you've struggled with memory management in order to get things to work within that 640K limit. Some other limitations that you have with DOS is the fact that it's single tasking. You can only run a single program at once. And that DOS is really only a character-based user interface. Certainly some very creative things have done with creating more user-friendly environments with DOS. However, the basic capability is character-based only. Well, Microsoft recognized several years ago that there were some things that were lacking about DOS. And they'd seen the work that had been developed by Apple. They'd also seen some of the work coming out of Xerox PARC into graphical user interfaces. And so Microsoft came out with something called Windows, first Windows 1.0 and then 2.0. And the attempt there was to make DOS more user-friendly. But it was really only, I think, a very first step in that basically what the Windows did is they provide a rectangular area within which a DOS application ran. But there was very little done to exploit the capabilities of a graphical user interface. However, some of the things that it did do is it helped resolve some of the conflicts between programs, and it made it easier for the user to move around from one application to another with the use of key sequences or a mouse. And it made the system look multitasking in that you had the output of various applications be able to be displayed simultaneously. But in fact, only one application was ever really active at any one time. Now, it was with Windows 3.0, which was released in 1990, where the Windows environment really took off. And people started buying Windows in great quantities. And more importantly, application developers started creating Windows-based programs. What made it successful? Well, number one, there was a big improvement in the desktop appearance. They added various families of fonts. They made the user interface look much more three-dimensional through the subtle use of shadow. There were many more user interface objects available to application programmers. In addition, you had a lot of powerful applications added, such as the task manager and the program manager, which allowed people to do very powerful things with a couple of movements of the mouse and a couple of mouse button clicks. You also had the ability with Windows 3.0 to get beyond that 640K barrier we talked about. With Windows 3.0, you had memory managers which were added that allowed you to do this. And suddenly, people could start using much more powerful applications within both the Windows and the DOS environment. And finally, Windows 3.0 added multitasking, although cooperative multitasking versus the preemptive multitasking that we see with Windows NT. But in fact, you were able to have several applications running at one time. Now with Windows 3.1, we have some additional features which were added. And again, this also helped to spur the popularity of Windows. One of the features which was added was TrueType. Now with Windows 3.0, you had fonts for different sizes. For example, in a word processor, you might have a 10-point type, then a 14-point type, then an 18-point type, but nothing in between. With TrueType, you can have as many intermediate sizes as you want. And what's more, TrueType looks much more, what you see on the screen is much more what you see when you get it out of the printer. So there was much more of a what you see, what you get environment added with Windows 3.1. Another capability was object linking and embedding, or OLE for short. With object linking and embedding, you can have data from one application, such as a spreadsheet, embedded within another application, such as a word processor. So your document might contain a small graph which was generated by that spreadsheet. This is similar in many ways to what we have with DecWrite and DecPresent and the feature called Live Links. You also had the addition of a new file manager which gave additional capabilities. And we'll see that with Windows NT, the file manager has even been improved more. You have the support for drag and drop, which is very Mac-like, I think. This is the ability to click on an icon, let's say an icon of a document, drag it over to the icon of an application, perhaps a word processor. And when you release that icon, the word processor automatically starts up with that document already loaded. A final thing that was added with Windows 3.1 is support for multimedia, for things such as sound and video. And the reason I go over all of these is the fact that Windows NT looks almost identical to Windows 3.1. And almost all of these features are also part of Windows NT, with the one exception that there are certain multimedia features which won't be available, it looks like, in the first release of NT. Another thing that influenced Windows NT, besides DOS and Windows, were some other operating systems. As I said before, the Microsoft engineers were able to pick and choose among some of the best characteristics of many of the operating systems today. Certainly, OS/2 was a big influence. In case you don't know it, Microsoft actually developed the first versions of OS/2 in cooperation with IBM. Then when the two companies got into some philosophical arguments as to the future direction of OS/2, And Microsoft decided they wanted to put all of their efforts behind NT. The Microsoft engineers that had worked on OS/2, many of them went over to work on the NT project. So you see a lot of similarities there. Another operating system which has some roots for NT is VMS. Dave Cutler, who's the chief architect of Windows NT, used to work at Digital. He helped develop the RSX operating system, Vaxilon, the real-time environment. He developed some components of VMS, and he was also working on an advanced operating system when he left Digital and went to work for Microsoft. Anyway, Dave is basically in charge of all of the engineers working on NT, and he certainly, I think, brought some of the features of our operating systems over there. Unix. Many of the features of NT are Unix-like. You see this particularly in the support for POSIX, but there are other features as well. And then I think something that might be as much of an influence as anything else is Mach. Mach is an operating system which was developed several years ago at Carnegie Mellon University. It's the basis of our OSF1 operating system. It's also being used by IBM for their RISC-based operating system. Next Computers, which has the operating system called NextStep, theirs is based on Mach. And Windows NT also shares many features with Mach as well, including such features as a small kernel or small core operating system, support for multi-threading, and support for multiple operating systems. Multiple file systems. Now, if we look, there are several different Windows families. It used to be simple. There was DOS and there was Windows layered on top of that. Now you have Windows 3.1. You have Windows 32S, which one of our callers asked about earlier. Windows NT, Windows for Workgroups, and finally LAN Manager for Windows NT, which, by the way, has recently been renamed the Advanced Server for Windows NT. Windows 3.1 we've talked about before. It's available now. It's a 16-bit environment. It's built on top of DOS. When I refer later on to something called the Win16 programming environment, or the Win16 API, I'm really talking about the Windows 3.1 environment. And as I said before, the interface is basically the same as what you'll see with NT. Windows 32S is a little bit hard to define in that it's both an upgrade to DOS and Windows 3.1 as well as a software development kit. What Windows 32S will allow an application programmer to do is develop a program which can run both in the current Windows and DOS environment, the 16-bit environment, as well as in the 32-bit Windows NT environment. And that's without doing any recompiling and linking. So what it looks like is a lot of developers will be first porting from Windows 16 to Windows 32S, and then perhaps as they want to incorporate more Windows NT features, they'll move from Windows 32S over to Windows NT. The S is short for subset, and basically it supports a subset of the Win32 API. There's one of the key things that will be supported with Windows 32S in the first release is the support for the 32-bit flat memory or virtual memory environment that NT has. Then in the future, other NT features such as support for multi-threading will follow. Now, one of the chief benefits of Windows 32S is that people can start taking advantage of the 32-bit environment that the Intel processors have today, but which aren't really taken to the full advantage by DOS and Windows. And they won't have to get the amount of hardware that they need today to run Windows NT. So I think you'll see a fairly wide acceptance of this. In terms of what it means as an upgrade to DOS and Windows 3.1, it hasn't actually been defined yet by Microsoft, but it looks like it'll be several dynamic link libraries which will have to be added. Dynamic link libraries, if you're not familiar with them, are very similar to shared libraries in a VMS or a Unix environment. Again, Microsoft hasn't clearly defined how this is going to be packaged, so we'll have to stay tuned on this. Now, Windows for Workgroups is another product which has been released approximately three months ago. What Windows for Workgroups is it's really an upgrade to Windows 3.0 or 3.1 that provides a Windows desktop with peer-to-peer networking capabilities. In other words, now my system, which is running DOS and Windows for Workgroups, can share printers and files. In addition, it can access printers and files that are out there either in a LAN manager environment or in the Windows for Workgroups environment. So in other words, if I have a partner that I work with in a lot of projects, we can share our we can store our common files on one user system and have us both access them. In addition to that, the file and print sharing, there's also the ability to share mail, and there's a network-based scheduling package that's available, as well as networking dynamic data exchange, which allows you to do cutting and pasting across the network. Now, how does Windows for Workgroups get positioned, or where is it most useful? I would not see this as a network operating system for large enterprise-wide environments. I think it's much more suitable for environments of maybe 10 or 20 PCs which have never had networking before. It might be positioned against a product like Novell NetWare Lite or the LANtastic PC networking product. They've made Windows for Workgroups as easy to install as possible. It's just like installing Windows today. In fact, there's a special kit you can get for Windows for Workgroups, which includes 2 networking cards. It includes a length of Ethernet cable, 2 licenses for the software, as well as a videotape which steps through exactly how to install it. And having done it myself, I know it's quite easy to do. So if we put all of this into perspective, everything that we've talked about before, down in the center you have Windows 3.1 built on top of the graphical user interface and the cooperative multitasking. You have Windows for Workgroups, which adds the ability to share printers and files and mail and to do scheduling and so forth. Remember again that they're both built on top of DOS. Then outside of that, you have Windows NT, which is a separate operating system that includes the 32-bit environment, multi-threading, multitasking, multiprocessing. Let me just go to the monitor for a second and show you where I think Windows 32S fits in. I see Windows 32S as really being a bridge between the DOS Windows environment, which we have here, and the 32-bit environment over here. Again, it's going to allow people to write applications which are shared and can run in both that 32-bit environment as well as the 16-bit environment down here. Now, the one product we haven't talked about yet is the LAN manager for Windows NT, which was recently renamed the Advanced Server for Windows NT. That really falls, I think, as a separate box outside here, because it takes the capabilities of NT and adds to that. So now we've come to that product, LAN Manager for Windows NT. Again, it's been renamed the Advanced Server for Windows NT. And what this is designed to be is really a full-blown network-oriented version of NT, which will give you many more powerful capabilities than a standard Windows NT environment today. Windows NT, remember, will allow users to set up peer-to-peer networks, much the way Windows for Workgroups does. What Windows NT Advanced Server will allow you to do is to add network administration capabilities. Under LAN Manager, what you have is the ability to create domains of PCs. A domain is basically a collection of PCs that has a central server which has information on the users which are part of that domain, as well as networking configuration information. Within the domain, you can also set up who from other domains can access you. So, for example, you might have a domain for your maybe your research group, one for your financial group, and another one for your management group. And you may want to set it up so that the managers can access information on the financial domain, but you may not want to go the other way around. Some other things that the Windows NT Advanced Server adds are various services such as a replicator service where you can have backups of that domain information on other servers. You'll have remote access services, as well as Macintosh services, which will allow Macintosh systems to gain access to this environment. Now let's back up for a second and talk about the LAN Manager product today. So what we're talking about right now is LAN Manager as it exists prior to Windows NT. LAN Manager is Microsoft's premier networking software. While it has never been as successful as a system such as Novell NetWare, it is still used in a large number of organizations. Right now, LAN Manager runs as an OS/2 application. The reason for that is because OS/2 is multi-threaded, it's multitasking, and it's very suitable for a server environment. So Microsoft basically developed it on that OS/2 platform. And what it does is it allows you to connect a variety of PCs and Macintoshes into this server, which in turn would serve up things like files and applications. LAN Manager includes two network protocols as standard features. One is NetBEUI, which I talked about before, as well as TCP/IP. And again, the OS/2 server, which LAN Manager runs on, is multitasking and multi-threading. PathWorks is also, which is of course Digital's premier networking product for the PC environment, is layered on top of LAN Manager. Okay, so LAN Manager is the base for PathWorks. And there are LAN Manager components used throughout the PathWorks product. Now what PathWorks does is, besides providing a wide range of applications and terminal emulators, also add some additional transports, such as DECnet, LAST, and LAT. In that small diagram at the bottom, what I'm trying to show you there is that the way LAN Manager exists on OS/2 today is it's really a layered product on top of the OS/2 operating system. And over on the left-hand side, you have the OS/2 file system, which is called HPFS, or the High Performance File System. The difference with the NT product is that the LAN Manager capabilities will be inherent throughout the different levels of the operating system. So for example, within the kernel and within the device drivers, there's networking support. It's not a layered product. So again, just to review some of the things we've talked about, LAN Manager for Windows NT has been renamed to be the Windows NT Advanced Server. It's designed to be an enterprise-wide server. In other words, it will be, Microsoft will be positioning this for environments where you have a large number of users and you want to split them up conceivably into separate domains. It's going to allow you to do things like configure file sharing and printers on a server system and allow access by a variety of clients. It will support other client services, for example, allowing you to do remote system management. Some of the additional features include advanced fault tolerance support. For example, with the LAN Manager for Windows NT product, there's going to be the addition of support for disk striping and disk mirroring on top of the volume shadowing that comes with a standard Windows NT product. And again, the other feature is network administration services. So you don't have to move around to every PC in your environment to simply set up things like users. Another set of services that will be layered on top of advanced server product include a set of Sna services as well. What this will allow you to do is to basically connect up to IBM mainframes. It will include both a set of APIs as well as support for the standard Sna protocols. These services will be used primarily by system integrators who want to do things like create specific IBM terminal emulators or want to create client-server applications where the server is perhaps the IBM mainframe and the client is your desktop running Windows or Windows NT. Another server product which currently exists as a layered product on top of OS/2 and is now moving over to Windows NT, very similar to LAN Manager, is the SQL Server product, or sometimes called Sql Server. SQL, is, I'm sure most of you know, is short for the structured query language. And what this does is it allows somebody sitting at a desktop who makes use of this server to access either the SQL Server database or databases which are existing on other systems, such as a VAX system or an Alpha system running a database product such as RDB or Oracle. The purpose of a product like SQL Server is, again, to help you with client-server computing and to really distribute the workload among many different systems. And to really get to that vision of creating a balance between personal, workgroup, and enterprise computing. And let's see how that's done. Over on the left-hand side, we have our various desktops, and those might be running DOS, OS/2, Windows NT, or what have you. And within there, you would have a graphical user interface or an application which included displaying data from a database, or perhaps would allow you to modify the data from that database. In the middle, you have the SQL Server itself, which again today exists as a layered product on OS/2 and will exist as a layered product on Windows NT in the future. The SQL Server consists of a database itself. It's based on the Sybase database system. And it also includes, besides the database itself, methods for translating database queries to the language which is understood by the mainframe or the mini-computer database environment. So on the right-hand side of the picture, you might have, again, a VAX system, an Alpha system. It might be an IBM system, which is running some products such as RDB, Oracle, Informix, or what have you. All of the database management work is put onto that mainframe or mini-computer system. So again, what you're doing is you're splitting things up. You've got the graphical user interface management being done on the desktop. You're having the translation and the passing of database requests and replies being handled by the SQL Server. And on the right-hand side, you have the database management being managed by the mainframe or the mini-computer. Now, we've spent quite a bit of time already today talking about Windows NT and all of the exciting features that Windows NT is possibly going to offer us. It's important to keep in mind that Windows NT is not a product yet. Okay? Right now, Windows NT is in the process of being beta tested. There was a beta version that was released in October, and another beta version is being eagerly anticipated, and we expect that to be out within the next month. Right now, most of the operating system features are complete. In other words, you can install it, you can use most of the functions, you can do a variety of system management and application development tasks. However, some things like complete documentation, complete online help are definitely not there yet. The way that it's distributed right now is as a beta test software development kit. And the current kit, which is distributed on a CD-ROM, supports the Intel platforms, so 386 and 486 systems, as well as certain MIPS 4000 platforms that have been designed to run with Windows NT. The operating system, as I said before, is distributed on a CD-ROM, and when Windows NT is finally released, when there's the full supported release, later on in the first half of this year, alpha support will be included on that. The expected announcement date for that is around May 25th. And we expect to announce, well, actually, Microsoft will be announcing the release of Windows NT. Digital will be announcing the Alpha PC as well as the support for Windows NT on that Alpha PC. Now, if you wanted to go out and order the preliminary software developers kit or the beta software developers kit, you need to recognize that this isn't going to run on just any old PC. Because of the larger size of the operating system, you're going to have to run it on at least a 386 system, preferably a 486, and a minimum of 12 megabytes of RAM. 16 megabytes are really recommended, especially if you're going to do any kind of software development work. There are people who've gotten it to work on 8 megabytes, but it really does not work very well. For the MIPS R4000 systems, you need at least 16 megabytes of RAM. Now, as much of a hindrance as the memory requirements might be, there's also the issue of the distribution media and the where you're going to store the operating system. The software is distributed on a CD-ROM, so you either have to have a CD drive attached to your system as well as an adapter that you plug that CD drive into, and Digital sells several adapter cards depending on whether you have an ISA or an ESA bus, and they also sell a variety of CD readers. In addition to that, you're going to need about 70 megabytes of disk space if you want to install both the Windows NT operating system as well as the software development environment. In addition to that, you're going to need an extra 20 megabytes of memory for a paging file, because this is a virtual memory system. So all told, you're talking about 90 megabytes of disk space. If you aren't interested in the software developers tools, you could get by with 30 megabytes of disk space for the operating system as well as an additional 20 megabytes for the page file. Okay, so you can get it down to a smaller size if you have to. When Windows NT is finally released at the end of May, they'll be able to get the hardware requirements down a little bit. For example, on the Intel platform, it looks like we're going to be able to run it on a system with 8 megabytes of memory. For the MIPS and the Alpha systems, it's apparently going to be at least 16 megabytes of memory that's required. In addition, I think the disk space requirements should be somewhat reduced from the figures that I gave you. In either case, unless Microsoft announces something differently between now and May, you will continue to need access to a CD-ROM in order to do the installation. One thing I should have mentioned before is that you don't need local access. You could, for example, put a CD reader on a network server, and then via DOS, you could install Windows NT on your local machine. There is a DOS to Windows NT installation program available. One thing I would also say about installing Windows NT is that installing the operating system and the software developers kit are two separate operations. And I've had a couple of people come up to me and say, gee, I installed the operating system, but there are no software developers tools. And you simply have to read through the manual, and it will tell you how to do both of those procedures. What we're going to do now is we're going to show a demonstration of Windows NT. And this this demonstration is going to look at NT from a user's perspective. So we're going to look at what the user interface looks like. As I mentioned before, NT looks a lot like Windows 3.1. And in fact, you may be a little disappointed that it's not some new, unique environment. Then I'll go through showing you some of the applications, such as the main program group, the accessories, the startup, and so forth. In addition to that, we'll look at some of the new program groups, such as administrative tools and the software developers kit. We're not going to explore those in any detail right now. We're going to do that later on during the technical overview. Okay, so sit back and enjoy a demonstration of Windows NT.
In our demonstration of Windows NT from a user's perspective, the first display that you see when you boot up the system
is this screen shown here. In the background is what is called Windows Wallpaper. This is simply a bitmap which can be selected by the user. In this case, this is the default bitmap that indicates that this is the October 1992 beta version of Windows NT. What's more important, really, is the welcome window that you have here that says press Ctrl-Alt-Delete to log on. By pressing that sequence, we're going to enter into the security subsystem. Now, this particular sequence of Ctrl-Alt-Delete may seem a little ironic to some of you DOS and Windows users because, of course, under DOS, pressing Ctrl-Alt-Delete will cause the system to reboot. However, in this case, we're entering the security subsystem. So let me do that now. And we now have this window displayed. In the username box, I can select one of several different users who are registered on my system. In this case, I'm going to leave it with the default value of Wise. In addition, if I'm in a LAN manager environment, I can select one of several domains which I can log into. Because I'm not on a network right now, I'm just going to leave it with the default domain of Toshi. And finally, down in the password window, I would type my secret password. And now we're logging into the Windows NT user environment. For those of you who are already familiar with Windows 3.0 or Windows 3.1, this probably does not look very different to you. Again, we have our program manager window in the background, and then within that we have the program group main with some familiar applications. And down at the bottom we have additional program groups such as accessories, administrative tools, games, startup, the Win32 software development environment, and a program group which I set up for this particular demonstration called Win32 Demo Programs. Now if we move up to the top menus here, by selecting File, again, we see that it's many of the familiar choices that you may have seen under Windows 3.0 or 3.1. One of the main differences is that where it used to say Exit Windows, it now says either log off or shut down. Because besides shutting down, there really is no alternative to that Windows environment, unlike what you have with Windows and DOS. I also have familiar options, familiar window arrangements, and help. Let's move down to the main program group and select File Manager. Again, this should look familiar to those of you who have used Windows in the past. What may look a little bit different is the toolbar up at the top here. This is a toolbar which was added with Windows for Workgroups and has been carried over to Windows NT as well. Most of these have to do with allowing your directories to be shared by other users on the network, and also buttons which allow you to access remote directories. Down here, I have my typical displays of different files and directories. On my particular system, I have one large hard disk, which is divided into a C partition and a D partition. And we'll be looking at these a little bit more later on. Another thing which is different in the file manager with Windows NT as opposed to Windows 3.1 and 3.0 is security. Because under Windows NT, I can set such things as permissions of files and directories. I can audit the access to files and directories, and I can modify who is the owner of particular files and directories. We'll look at that more a little later on. Let me exit out of the file manager for the moment and go to Control Panel. Again, this will not seem too strange for a lot of you who have used Windows before. You have typical small applications such as color, fonts, ports, etc. Let's take a look at internationalization. Here we can specify what country we're running the system in and what language and keyboard we want to use. In addition, we can modify such things as how the date's being displayed, the currency format,
the time format, and so on. In addition, we can set up our networks if we're on a network. Now, what it's showing me right now is that I have a default domain called Toshi. If I had a network installed, I could go to Advanced Feature and configure myself into an existing LAN manager or other environment. One of the additional features of Windows NT is that you can load and unload device drivers. With the drivers application, I can list what device drivers are currently installed, and by selecting the Add button, I can select additional drivers as well. When the next release of the Windows NT beta software becomes available, you'll see a lot more drivers added to this list. Now, in a real situation, if I were to be installing these, I would have to read these drivers off of my CD-ROM. I don't have that installed on my system right now, so I can't complete this aspect of the demonstration. Let me close up these windows, and we'll go to Server. This is telling me that the server service has not been started. Again, this is because I'm not on the network right now, although I do have a network card in my system. So I'm going to say right now that no, thank you, I don't want to start that. In addition, we have a services control panel. These are different services which can be started up automatically at boot up time or can be manually started later on. These are typically services associated with networking. For example, we have the event logger, which is running at this time. We have NetBIOS transport, TCP/IP, Telnet, and UPS, which is responsible for various services associated with uninterruptible power supplies. You can use this to start up a service. You can also use it to stop it. And finally, we have a control panel selection specifically related to uninterruptible power supplies. But because, again, I don't have one of those on my system, I won't show you anything with that right now. Let's get out of the control panel and move over to the MS-DOS prompt. Now, this icon is actually misnamed to a certain extent, because with this application, not only can you start up MS-DOS applications, but you can also start up Windows 16-bit applications, 32-bit Windows applications, POSIX, or OS/2 applications. With that said, let me double-click on this icon, and we get a window appearing. This is a console window. The actual application which is running is something called the single command shell. It's called that because, again, you can start up numerous families of applications from the single window. The first one I'm going to start up, the first thing I want to do is show you some of the standard Windows NT applications. Most of these are familiar to you if you use DOS today. They've simply been converted over to the 32-bit Windows NT format. Let me start out by displaying help. And here you have a list of various commands, which again you should be familiar with from DOS if you've used that before. Commands such as cd, comp, copy, date, echo, etc. If I take a closer look at one of these commands, such as the format command, we can see by the display that it's been modified for Windows NT. Up at the first line it says formats a disk for use with Windows NT. And further down, if we closely examine some of the options, we have a new option for format called FS, which allows us to format a disk for a particular file system, either the DOS file allocation table format, the OS/2 HPFS format, or the new NT file system format. Again, this is just one of many commands that has been changed and upgraded for Windows NT. Now, what I'd like to do at this point is execute a DOS command. And when I execute the DOS command, what's actually happening behind the scenes is that we're creating an application or starting an application called the virtual DOS machine. The purpose of this virtual DOS machine is to recreate the DOS environment so that the application thinks that it's running in native DOS. Now, when you boot up a system running DOS, what happens first? Well, you have two files executed, config.sys and autoexec.bat. That same thing's going to happen when I start up a DOS application on the system right now. You're going to see some messages quickly scroll by, and that's my config.sys executing, followed by my autoexec.bat executing. And then finally, we'll get into the application. The application I'm going to show you is Edit, which is the MS-DOS editor. So again, watch what happens when I hit the return key. Config.sys, autoexec.bat, and here we are with the MS-DOS editor. So what happened at that point was we started up a virtual DOS machine, which is now handling our edit application. I can go back to this main window, create another single command shell, and execute a different DOS command. Let me execute the DOS shell. And because I'm starting this from a second window, I'm going to be creating a second virtual DOS machine. So again, we'll have config.sys and autoexec.bat being executed first. Okay, so we have the MS-DOS shell running here. We have the editor running here. And so in a way, what I've done is I've created a multitasking DOS environment, because both of these applications are taking their share of the CPU time. All right, let me get out of the edit application, and I'll get rid of this window by simply typing exit. I can also exit from the DOS shell. The second type of application I'd like to demonstrate is running Windows 16-bit applications. Remember that this native format is a 32-bit environment. However, I have loaded onto the system an application called QuickC for Windows, which allows you to write 16-bit Windows applications. Let me start by changing to the directory where those executable files are located. I'm going to a directory called qcwin/bin. And if I do a directory of all the exe files, we see a variety of 16-bit executable programs. Now what I'm going to do is I'm going to start up the main application, which is called qcwin. This application is going to take approximately 10 seconds to get started. The reason for that is when I execute my first 16-bit application after logging into the system, I have to initialize a special environment which includes the virtual DOS machine as well as some additional software which is specifically for the Windows 16-bit environment. The environment is sometimes called WOW, for Windows 16 on Windows 32. I also want to show you a new command called start. What start will do is it will allow me to launch a Windows application and then get my prompt returned directly so that I can then go back to that console and start another application. So I'll type start qcwin. I'll hit return, and notice that my prompt immediately returns. In addition, you'll see that the cursor over to the right of the directory display has both an arrow and an hourglass. This is indicating that something is happening in this window, but I could go to another window and do something else if I wanted to. Okay, here's my first 16-bit application, QuickC for Windows. And again, it's a fully functioning environment. I just have a lot of menu choices grayed out here because I don't have any files loaded at the current time. Now let me go back to my single command shell here. And what I'm going to do is I'm going to issue another command called qcasew, which is a case environment for which makes it easier to create Windows applications. What I want you to notice is that this second application will start up immediately because we've already initialized that WoW or Windows 16 on Windows 32 environment. What we now have displayed on the screen is our Quick C for Windows, the application we started first, and Quick Case for Windows. At this point, I could go back to my MS-DOS prompt and type in exit, getting rid of the console window, but I still have my full 16-bit Windows environment displayed. I could have also started these applications from an icon, but I wanted to demonstrate to you how the single command shell works. I'm now going to exit these applications just to keep things simple on the screen. And I want to end this demonstration by showing you some of the features of preemptive multitasking and multithreading, which we talked about earlier today. So I'm going to open up a different program group called Win32 Demo Programs. When you get the Windows NT CD-ROM, there are two steps in the installation. One is to install the operating system itself. The second installation procedure is to install the software development environment. The software development environment will actually create this program group that you see here, including various editors, utilities, and online help. We'll look at this program group some of the features of this in a second. We'll also look at it in more detail tomorrow during our technical overview. Let me close this back up for a second. And when you install that software development environment, it comes with about 35 sample applications. For the purpose of this demonstration, I've compiled 2 of those applications and put them in their own program group, which you see here. The first application is Gdi Demo. This will demonstrate some of the graphical capabilities of Windows NT. The second one, Multithread, is a demonstration of how to write a multi-threaded Windows NT application. Let me start with opening up Gdi Demo. And with this demonstration, we can demonstrate various graphical operations, including Bezier curves and drawing random objects. I'll do both of those. And I'm going to arrange them in a tiled fashion, and we'll move them up into the left-hand corner of the screen. Next, let me start up multithread. When I start up any application, the first thing that happens is a process is created. For every process, you have at least a single thread. Right now, multithread is running as a single-threaded application. I'm going to now go down and select the menu item Bounce, which is going to create a new window, which is also running as a separate thread. Let me do this several more times. And again, allow me to tile these. Okay, we'll now move that over to the lower right-hand corner of the screen. We'll bring Gdi Demo up to the foreground. And now we have everything running simultaneously. Now, there are a couple of things that I'd like you to observe. Notice what happens when I move the mouse and the input focus from Gdi demonstration over to multithread. Multithread now has the input focus. We talked before about how Windows NT incorporates preemptive multitasking. The preemption is the ability for certain applications to run at a higher priority than other applications, and for those applications which are running at the higher priority to have more chance to run on the CPU. They get more CPU cycles. Because multithread now has a higher priority than Gdi Demo, you'll notice that the Gdi Demo in the background has slowed down almost to a halt. If we move the input focus back to Gdi Demo, we see that it's, the graphics display speeds up again. Now notice something else. Multithread, which we might expect to have slowed up once Gdi Demo got the focus, is still operating at a very nice clip. The reason for that is that multi-thread is a multi-threaded application. And so that even though its priority is lower in relationship to GDI demo, because it has more threads, each of those threads is getting scheduled on the CPU, and it continues to run at that higher level of performance. Again, if we move back to multi-thread, GDI demo slows down. Now, let's say that even though we want GDI demo is in the background, we want it to be able to update faster than it's doing right now. One of the ways I could do that is to modify the priority of GDI demo. In order to do that, I'm going to go and open up another application. One of the applications which comes in the software development kit is PView, short for Process Viewer. This application allows us to examine the processes which are running, look at the memory that they're using, look at the threads which are associated with those processes. Up in the top window of Process Viewer, we have a list of all of the different processes which are running. And we can highlight various processes to get more information. For example, I now have the event logger highlighted. And down in this lower box down here, we have a list of all of the threads associated with event logger. And we can see that that application is written using 5 threads. I'm going to refresh the display, and we'll see that GDI demo is here. Let me highlight that, and you'll see that that GDI demo is a single-threaded application. Again, that's part of the explanation for why when that goes to the background of the screen, its updating occurs at a much slower pace. On the other hand, if we select multi-thread, we can see that that contains 5 different threads. Now let's go and raise the priority of GDI demo. I'm going to do that by selecting it and then going to this window which allows me to modify the priority, and I'm going to move the priority to very high. And now let's bring these applications back into the foreground, and we'll see that even when GDI demo is put in the background and multi-thread has the input focus, GDI demo continues to update at a very good clip. The final thing that I'd like to show you in this demonstration is the rebooting of Windows NT. Unlike Windows and DOS, you want to be careful about how you reboot the system, both so you close out your applications properly and also so that you retain the integrity of the file system. There are, let me start first by just exiting out of multi-thread, the GDI demo, and finally let me kill this process. Again, there are 2 ways that I can select to choose to log out or shut down the system. One is by typing Control-Alt-Delete, or I can go to the Program Manager and select Log Off or Shut Down. I'm going to select Shutdown. At this point, I can tell the system that I want to restart once I've booted the system down, so it will automatically reboot. Or I can say that I don't want to, and this would be the case if I wanted to power the system down. Just for purposes of demonstration, let me show you what happens if we deselect Restart and then say, yes, we want to continue. The first thing that's happening is all of my applications are being closed up. In addition, any files which are open are closed properly. In a moment, the windows will start disappearing, and we will get back to our original display. And the one thing that is different is now it says it is now safe to shut down your computer or to turn off your computer. Instead, I'm going to select Restart. When I select Restart, you'll notice a couple of things happen. I'm going to boot all the way down. Then it's going to come back up with an option called Flex Boot. Flex Boot allows me to either reboot Windows NT or to boot up my previous operating system, which could be either DOS or OS/2. In my case, it happens to be DOS. I'm going to boot up Windows NT as my choice. Let me show you what happens. Okay, we brought the system all the way down. It's now loading the Bootstrap program, which takes a couple of seconds. And then what it's going to do is call in the operating system loader and then finally the Flex Boot option. And here you can see that it allows me to select either Windows NT or the previous operating system and gives me 30 seconds to make my choice. If I don't make a selection in that amount of time, it will automatically boot up NT. Now, as the system's booting up, notice several things. First of all, you'll see very quickly displayed the NT kernel loading and then various device drivers. Okay, now it's automatically going to the boot up process. And now what we're doing is we're checking the integrity, or Windows NT is checking the integrity of the file system, both my D partition and my C partition. Both of those volumes are clean. So now we return to our login window. Thank you. This concludes our demonstration of Windows NT from a user's perspective. Let me just remind you that you too can get a hold of this Windows NT Software Developers Kit. I'd suggest this for anybody who wants to learn more about Windows NT. And a little later on in the course of today's program, I'll show you how you can obtain that software. You've already learned a little bit about the type of hardware that's needed to run it on, and we'll tell you about the software that goes with that. When I demonstrated those programs, the Gdi Demo and the multi-threaded program, remember that those are only 2 of about 35 applications that actually come with the system. And there are others which are also equally fun to look at and to show your customers. One that's being used particularly on the Alpha platform is a Mandelbrot demonstration which shows the use of fractals. And because of the use of the floating point in that application, it shows up particularly well on the Alpha PC. Okay, we have a call from LA. Hello. Hello, LA?
Basically, the first question is, what are the disadvantages if I buy a Jensen or an Alpha PC?
Okay, we'll get to that. If you can just hold on for a second, in the next section, which we'll be going into right after the question and answer and the break, we'll be talking specifically about the Alpha system and what its potential weaknesses might be.
I guess the other question is, what are the applications and the effective applications on, when they ship? For example, I need to buy a Lotus 123 for Windows Alpha or one for Windows Intel.
Mm-hmm. How is that going to be done? We're right now, the people within the Windows NT program group are actively recruiting these software companies to port their software over to the Alpha platform. And there's a couple of different approaches being looked at for distribution. Certainly one of them is going to be a common CD-ROM that would have the binaries for both the Alpha platform as well as the Intel platform on it. But again, I will get into more detail on that in the last portion of the show today.
Are there any other semi-real applications that we can show customers today, or is just Mandelbrot the only thing that's available?
Semi-real, yes, especially if you have a networked environment. There are several client-server applications that are available as part of the Software Developers Kit. Another example is there's a package called the Hamilton C Shell, which is available both on the Intel platform as well as the Alpha platform. I don't have the number for how you can order that, but I believe you can find it in the Windows NT Notes Conference, which I'll also be telling you about in the next few minutes. So yes, there are some now. There should be some more
coming up over the next few months.
Thank you very much.
That's one of the ones that also comes to mind is an application called FrameMaker, which you may be aware of, which allows you to put together very complex documents. This is available on both platforms. We have another call from Tulsa. Hello.
Hello. Wanted to know if you have any idea about how fast Alpha will be, or how fast NT will move across the whole Alpha line.
Again, if you wouldn't mind, I'd like to hold off the Alpha questions until the next chapter, where we will be talking about digital and the Alpha product. That doesn't mean I want to ignore your question, but I would like to hold off on that. Okay. Anything else? Marlboro, hello.
Hello.
Yes?
Two questions, really. The advanced server for NT that you talked about, will it support not only Windows NT systems, but Windows 32, Windows DOS, Macintosh, OS2? What type of platforms will it support?
Yes. First of all, a lot of the details are still a little bit sketchy in that Microsoft has not yet released a beta version of the advanced server for Windows NT. It should be out about the same, within the next month or so, and is expected to be released about the same time as the standard Windows NT. But it will be able to support, yes, not just Windows NT clients, but also PCs that are running Windows or DOS or Macintosh. Yes.
What about things that are PCs that are running Unix?
That I'm not sure about.
Okay. The second question is that you mentioned that there's TCP/IP built into Windows NT for the specific PCs. Can you then use existing SNMP managers in the marketplace? And if not, why not?
That's a very good question. And again, I'm not sure of all the details, except to say that I know the LAN manager does have support for SNMP. If you were going to name a specific one, I really couldn't say at this point which ones are supported or not.
Okay, thanks.
Okay, Westfield, you have a question.
Yes, you had mentioned earlier about that LAN manager, which like you can share between 2 or more PCs, and also their printers. Does this also mean that if PC A were to communicate to a printer located on PC B, would the person now using PC B be shut off, or does it actually run more than one process at a time?
Right. There is a print manager which allows you to basically queue up the different printing jobs and to handle them in a sequential fashion. But it won't cut one of those PCs out of the operation while another one is actively printing.
Oh. Okay, thank you.
Sure thing. Any other questions? Las Vegas, hello.
Yes, I keep hearing that we're going to be providing NT across the entire Alpha platform. And my question was, I haven't seen anything but a graphical user interface, and how are we going to do that on systems that don't have, that aren't workstations?
Right. Again, that's going to be a question we're going to talk about in more detail next, but let me just say that right now the support is limited to the Alpha PC, the Jensen product. It will be spread out into those onto the higher end platforms. They might not be all the platforms which necessarily exist today, and there's going to have to be some work done on both the hardware and the software, so that we can do, just as you say, get a graphical user interface onto some of those higher end Alpha systems.
Okay, thank you.
We have a question from Tewksbury.
Yes, there is the PostScript documentation that comes with the kit.
Mm-hmm.
Is there a way of printing that from NT Windows itself?
I think what you would have to do there is you would either have to have a PostScript printer locally attached to it, and I've heard of people that have been able to do that. In addition, if you set your Windows NT up into a networked environment, you would be able to print it in that way as well. So yes, I have had people be able to print those PostScript files.
Thank you.
New York City.
Yeah, question that I have regards the MS-DOS environment. Is there any way to prevent the reinitialization of DOS every time you start up a DOS application? Is there a way to keep the DOS system resident?
Actually, I don't believe I demonstrated that there, but within the context of a single console window, you do have that DOS environment continue to be initialized as long as you continue to run DOS programs. For example, if I had exited from the edit application and then started up something like the DOS shell, you would not have seen config.sys and autoexec.bat re-executing because, right, that same virtual DOS machine would have continued to run. However, if you're doing it from two different console windows, yes, those are going to be two separate virtual DOS machines.
Great. And the other question I have is, the Bootstrap environments are supported. You mentioned OS/2, DOS. What other environments support a Unix environment?
No. Right now, the environment includes, at least on the PC, includes, as far as I know, OS/2 and DOS and Windows NT. That's all. There may be something else on the MIPS environment, but I'm afraid I haven't explored that and don't know the answer to that one.
And of course, the Jensen won't support the DOS environment natively on native Bootstrap.
Right. To just review what we've talked about in this chapter, Windows NT is really an extension of the Windows family. And Microsoft's goal, as I said before, is to really spread Windows from everywhere from that laptop or desktop device right up to the highest end system. There will be the ability to interoperate with classical multi-user environments, but Windows NT itself really isn't designed to support that. We also talked a little bit about the different environments that it supports, and in tomorrow's technical overview, we'll take a closer look at how the operating system is able to run things like DOS and Windows 16 side by side with Windows 32. And we talked also about the compatibility with the existing applications.